about myself. I think most of you know me, the guy with the HTML5 license plate, the author of the Pro HTML5 programming book. Basically, HTML5 is all I do, and I work at Kazing, focusing on technical training in the HTML5 area. All right, so quick agenda. I want to talk about all of the different APIs that make up HTML5 communication. And there's quite a few, and there are a couple of concepts in there that are important, so I'll sprinkle those in there. And one more technology that's not really part of HTML5. I don't want to put it under HTML5, but I think it'll be interesting because it's so closely related, which is Speedy. So we'll talk about these in this order. And basically, I wanted just to point out, for those of you new to HTML5, HTML5 is pretty large. And there's many different feature areas, from markup to the connectivity we'll be talking about, to the canvas and other areas, and video and audio and so on. So as Remy Sharp pointed out, HTML5 is not something it's not an all or nothing approach. You pick the feature you want. Then I would like to add something like, well, the typical process would be you prototype with that feature you want, then you realize, okay, well, that doesn't work in all the browsers. Maybe then you use something like Modernizer that we talked about a few months ago and say, okay, which browsers have it? Find a good polyfill library. So in this presentation, I'll also point out a few of those that are related. For example, there's libraries and servers that provide emulation for some of the features we're going to be talking about. So I started working on this map of all of the different HTML5 features. It's nowhere near complete, I think, but it gives you an idea of any one of those areas blown out to be, any one of those is an explosion of new features. If you think about local storage and session storage and database storage, whereas in the past we had maybe just cookies, right? There's a lot there in all of the different areas. And we're going to be focusing on just one of those areas, which is that connectivity in real time. All right, so one of the main things about HTML5 is in its design goal has been to keep things simple. And it also, one of the sort of the ways that is described as paving the cow paths. For example, if you have a form with an input that you have to detect whether that's an email address, it used to be a crap load of JavaScript you had to write or pull in a library, and now it's input type equals email. Very simple. Now, the connectivity area is definitely one of those areas where paving the cow paths was really a welcome change, because that was one area where you had to use the craziest hacks to get things done. And so everyone that has some experience in that will really like the simplicity of these APIs. It's actually sometimes it's like, oh, that's all there is to WebSocket. I mean, it's really that easy. It really is. So the first concept I wanted to sort of talk about a little bit is the origin concept. Some new, just in last December 2011, a new RFC was published for the web origin concept. Right? The origin itself has been around for a long time. It's the combination of a scheme, host, and port. And all of those components, the scheme, host, and port, need to be the same, or communication will typically fail because of a same origin policy in the browser. And that's quite literal. And pay attention, because I will be asking a few quiz questions here and there, and this is going to be one of the subjects. So the origin is used to model a trust relationship on the web. So everything has a URL. Part of that is the origin, scheme, host, and port. So scheme would be HTTP or WS for WebSockets. The host is the fully qualified host name, and the port, 80 or 443 are the default ports, but there could be some other port. Now typically, the browsers enforce a same origin policy, and that's for your protection, right? That was introduced a long time ago, but as we're moving to more client-side rich applications, that's becoming a little bit too restricted. So we need something else, or we need something a little bit more relaxed, but at the same time, we don't want to lose that security, right? That's the number one thing. You don't want to be opening it up for vulnerabilities. So here's a quiz question for you. The first person to raise their hand and have the right answer can win a book, a copy of my Pro HTML5 book. Which of these URLs, and I'll give you a hint. Yes?
1 and 6.
Perfect. Excellent. So what I wanted to point out here is that 1 and 6 are the only ones that have the same scheme, host, and port, right? So it's the exact match. For example, the IP address that actually resolves to that same host name is not the same. The browser sees that as a different origin. And that's kind of important. You can run into a lot of small issues with that. Also, subdomains are not on the same origin. All right, so the first feature I want to talk about is the cross-document messaging. You'll see that origin concept coming in over and over, especially when we start talking about the cross-origin resource sharing. So cross-document messaging, and the reason why I picked it from cross-document messaging to XHR to WebSocket in that order is because it's sort of, you could say, from small to large, whereas cross-document messaging is intra-page or in the browser. It doesn't communicate with the server. It's just from, let's say, a page to an iframe or another tab, where then server-sent events and XHR communicate with the server. WebSockets is bidirectional communication with the server. So that it sort of gets bigger and bigger. And cross-document messaging, also known as the PostMessage API, allows you to pass messages back and forth, not just between the same origin, but even cross-origin. And we'll show you a little bit how that works. So first, a bit of a demo. There's a lot of HTML5 slideshow applications, and one of them was created by a guy from Mozilla, Paul Rouget from France, and he created what is called DZ slides. If you look at what is happening here, if I click around, then you notice that I'm controlling from a page, I'm controlling another page in an iframe. And that sort of communication is pretty typical for cross-document messaging. And it's actually, he's using the PostMessage API to send a small message to that page that's on the iframe, and it doesn't have to be on the same origin. So that's a powerful thing that you can open things up cross-domain. So that's just one example. And a lot of other things are, especially in what we talked about earlier, in Mobi specialty, the advertising, that's where you start seeing a lot of when third-party content comes into your page in an iframe, social like buttons and things like that, that becomes, then they're usually hosted on different domains, and that you start running into these same origin policies, and this is a good way around that. So the PostMessage architecture is, you use PostMessage to send a message. Now, on the receiving end, you need to add what is known as an event listener for messages that are coming in. And there's a couple of gotchas there. But when you send a message in JavaScript, you use the PostMessage API, you send the message and you pass in the target origin, as you can see there. And then the receiving end, let's say either the page, I mean it works in the same way in both directions. The receiving end has an event listener. It receives a message object. It detects to see, it checks to see which origin that came from, and then it makes a decision on whether to parse that or not. So that's the high-level architecture. So in JavaScript, that would look like this. You send a message or use post message, passing in the actual message, and that could be an object, it could be text, and then you can also send or you have to provide the target origin. That's an extra security feature. But what's important here is that the browser tacks on, as you could see in here, the browser adds your origin, and that's something that can't really be spoofed unless you write your own evil browser. But let's say that normally that cannot be messed with. So in that sense, it's secure. So you're not actually passing in your origin, but you're passing in the target origin. Then the receiving end adds an event listener for the message. That's a named event. It listens for that, passes that through a message, passes that off to a message handler, which checks to see the origin. If it's one of the list of trusted origins, then it goes ahead and does something with that message. So that's really the key thing, and you do that on both sides, of course. And anyone know another API that uses PostMessage? This is not for a book, but yes? Web workers, right, exactly. So web workers is always on the same origin. The difference there is you use PostMessage and you just pass the message in. You don't have to pass the target origin because that's assumed it's the same origin, because you cannot start a web worker from a different origin. It has to be same origin. Now, there's a really important detail here. You may have already seen that there's a pretty big vulnerability, or a possible vulnerability in here. If I go back to this add event listener, if I just said, look, I'll listen for messages and I don't check, as you can see here, I don't check the origin, but I immediately start processing it. Well, that could be a real problem. And the specification has, the first line of the spec is a giant red warning. Because you're using an event listener that cannot really be changed. It's effectively, you need to write that code yourself, and it's quite important. And there's actually quite a few examples out there on the web that don't do this at all. They just, take the message, parse it, and then you could open yourself up to quite a vulnerability. So this is quite an important detail. What you should be doing is using a whitelist of allowed origins. Okay, so this is actually a feature that's supported in IE8, right? So this is something you should really be able to use. This has been around for a long time. You can use that. And so there are emulations for older browsers. A couple of them, one of them is pretty widespread adoption. It's called EasyXDM. Another one is the Kazing WebSocket gateway that actually has an emulation for that, all the way back to IE6. And for those of you that don't know this, there's a great website, and I put links in here, and I'll hand out the presentation afterwards, so I'll put it on SlideShare. caniuse.com, that's your one place to go to see all of the browser support, and it'll tell you exactly which browser support it. Okay, I'm going to move on to the next section, which is CORS. So CORS stands for Cross-Origin Resource Sharing. There's a great site that I recommend all of you to look at if you're interested in that. And basically, when you start moving away from the intra-browser, intra-page communication like we just talked about with cross-document messaging, then you're very soon going to talk to a server. So you have maybe an XMLHttp request that you're making to a remote site. Well, there's a potential problem, because if that's on a different origin, you can't do that, right, with the same origin policy. So people have found, even there, a nice way around it. JSON-P. JSON-P can be kind of dangerous. It's JSON with padding. Effectively, what you're doing is you're taking a script. You're basically sending a message, and you're saying, here, you decide what script you're going to run on my page. So if that doesn't sound dangerous to you, then you probably weren't listening. So that's really not a great architecture. Now, HTML5 defines a new API, which is not an API, a new standard for allowing access to resources on a server, but by doing that by allowing that through a whitelist of allowed origins. So there's a standard that's now built around that that makes it easier to share resources from different places with each other. And so basically the big difference with XHR and CORS, using the CORS architecture instead of JSON-P, is that you're no longer getting code, but you're getting the data that you wanted in a safe way. So we'll take a look at that. So the course standard defines a set of headers, because right now you're moving from the page to another origin that is on another server, right? And this server, you need to communicate effectively that same origin property that we were talking about in cross-document messaging. You need to communicate that to the server. So how do you do that over the web? Well, you send an HTTP header, and the server responds with one. So on the one side, there is the origin header. That's different from the referrer header, a famous misspelling in HTTP. And that is just that origin concept we talked about earlier, the scheme host port. On the return, the server will allow you, it will say to sort of display which origins are allowed for that particular service. So what this really allows you, this is pretty powerful. It doesn't sound like much perhaps, but in the past there were a lot of problems with server-side aggregation being a necessity because of that same origin policy. For example, you have a page that has a stock portlet and a news portlet. Well, if they come from different origins, the browser would first need to talk to some sort of application server which aggregates everything and then serves it up from a single origin. Now the browser can go to a page, make cross-domain connections, send cross-domain, let's say XML/HTTP requests. By using that course standard, it can it communicates like I'm on this origin, and the server says, okay, on that origin you have access to this content, go for it. So now you can open it wide up and still in a secure way. So it's really protecting the server's resources. And if you look at the HTTP headers that come with this, and again I'll make the slides available online later, it sends the browsers that support this, they send an origin header, and on the way back the server will pass in different access control, allow origin, credentials, methods, and so on. So it sends it back access control headers. This is defined in that core specification. Something similar to this would be in Canvas. When you display an image on a canvas, the canvas becomes tainted if that image is from a different origin. So now similarly on Canvas you can define a cross-origin attribute that, you know, when you communicate and you get it from a server that does allow that, you can use that and get the image data from that canvas image. Right, so this, the core standard itself is supported in all these browsers. IE8 has something called cross-domain request, XDR, that does a lot of what this is doing. So it's not an identical standard, but it's close enough in many cases. And you do need for this a server that supports that standard. Now, XML/HTTPRequest is really where we use this, and also in WebSockets we will use this cross-domain capability. So XHR is the AJAX API, if you will. There were a couple of things lacking that have been fixed in XHR Level 2, and there are progress events, support for binary, and also cross-domain using the core standard. Now, in the past, the progress events were very hard to get. Like in some browsers, they wouldn't fire properly. The different ready states were numeric properties that you could get, and it was a bit of a hack. So now there are these named progress events that are supported by the different browsers that support the standard. And you can build very nice, you know, progress bars. There's even a new HTML progress element that ties in nicely with this standard. So these ready state and ready state change in typical HTML5 style are retained for backward compatibility. Now, the way you would use them would be something like building a status bar of how much you have uploaded or how much you have downloaded. So if you do an XHR get or post, you can monitor how much of that data has come to you and compute how much of it already has been loaded. I have an example of that later. So the cross-domain XHR, you can't really tell that that's a cross-domain unless you know the origin that you're making that request from. So that's something you can't really see. The API call itself hasn't been changed, but that you just have to know different origins are now possible. So if the server that you're talking to actually supports that communication, if it supports your origin in an access control policy. Now, binary data is also supported. You can have either blobs or typed arrays. This is really good for if you want to upload, let's say, files, right? There's a new file API that you can start using. You can make an XHR get or post, and you can start working with binary data for like audio and things like we talked about in the last event. So that's another thing you can do. There's a nice little demo. Let's see here. Right. That Eric Beitelman put together. So there. Like this is basically using, well, actually, let's see. Okay. I'm just uploading a PDF and there. So it did the binary support, a binary post. It also did a progress tracking using a progress element. So quite a few things at once at play there. But really the main thing here is that this is a much better standard for cross-domain communication than the variety of hacks that have been used in the past. And so this is supported pretty well. Like I mentioned in IE8, there's something, so just as a note here, Internet Explorer was the first one that came out with XMLHttpRequest. So then everyone else liked that idea a lot and they followed. So Internet Explorer already has had XDR, the cross-domain request, which is not exactly the same. It doesn't have the same support according to the spec, but it does the cross-domain part really well. And many times, if that's what you need, you can fall back, if you will, to that. So that's a good way to do that. Okay. You do also need some server support. So on the server side, this is not really hard, but I can give you an example of it. Okay, so. All right, so this is if you're familiar with Python, there's a simple HTTP server. So Python has a simple HTTP server, basically a web server in Python, and in about 39 or 37 lines of code, it's been extended to be a core server. How did it do it? Well, it's just all it needs to do is understand the origin header coming in and advertise the right access control allow headers. It basically needs to have a coarse implementation on the server. It's very easy. You can do this and you can set this up. Again, one of the things that's going out is out there in the wild that I would want to warn you about, and some examples have this, is where the default policy, as you can see here, I'll make it a little bit bigger, right? I'm saying access control allow origin, and I've put in a particular origin. That's something I have running on my machine. But many people will put the default to be star, and again, that's not a good idea. Just like the cross-document messaging, just opening it up wide. The best possible way you can do this is to start with a default deny policy and then open it up slowly. That's quite important, and there's tons of examples out there on the web that do this just by like quick prototype with a star. I'm sure some of that will have made it already into production, which is a real shame. But yeah, so in essence, it's not very hard to build a CORS compliant server. And Apache, There's some boilerplate project, has a couple of good sections in the documentation where you can take basically the Apache configuration and extend it. Okay, so I want to talk about WebSocket. WebSocket, if you want to build an application, let's say a financial trading application or social networking application or any one of these applications, gaming, system monitoring, anything with sort of a real-time component, but also what you can tell here is sort of a bi-directional component. So WebSocket is really good because it opens a socket where bi-directional full duplex communication can take place. So it's not just one-way server-side push, but bi-directional traffic. And there were many approaches that were used in the past that you've probably heard about. Comet and reverse AJAX are some of those. Those were pretty clever hacks on top of HTTP, letting HTTP do what a socket connection would do, but with some pretty fundamental problems. And the reason for that is that it was all based on HTTP. HTTP sits on top of TCP, and it basically trims it down to a half duplex connection. Half duplex meaning you can only speak in one direction at a time. Think of it like a walkie-talkie where I press a button, I hold open the channel, I speak, now I have to let it go and they can talk back to me. All right? So take a look at this example. I'm sure you've used this, you use this every day, right? You go to Google, you type in a few letters, and actually what's happening is, so just to take a step back here, the original idea, like the original idea about HTTP, there's nothing wrong fundamentally with HTTP for what the web was designed for, 20 plus years ago. And so to retrieve an object, you send some headers to the server, you say what you want, you get that object, done. And that's a static web, that's how the web was designed. But now, with AJAX calls left and right and very dynamic websites and constant updates, you have to constantly get new data into your page or either refresh the page or get a partial refresh. Now just take a look at this very simple example. Is an AJAX call that's going out to the server with the letters that you've typed. So if I very quickly type in HTML5, it takes that, it sends it to the Google search server, comes back, and just that XMLHttpRequest, that sort of post or get some data from the server, resulted in a 1,500, round about 1,500 characters being sent to the server and coming back. So about, I don't know, 1,000 going to the server and 500 coming back. Just that one HTTP request, because it's still using HTTP as a foundation. And the equivalent would be something like this. Let's say I wanted to talk to you. There's actually a pretty cool library. I'm not sure how well this will...
Welcome to this HTML5 beta.
All right, so I'll make it a little bit louder.
Welcome to this HTML5 beta.
Okay, this is what I want to tell you, right? Instead, you're talking to the server.
Get/http/1.1 host html5 please.com user agent Mozilla/5.0 Macintosh accept text/html accept language header accept encoding gzip deflate connection keep alive code a lot more data cache control max age equals 0. Hello, are you still there?
Exactly. Right? So the problem with all of that overhead is if you need to get a big file, a large HTML document or a PDF or whatever, it doesn't matter that you have some overhead. It's minimal compared to the size of what you're downloading. Instead, in most applications today, it's not the main page that we're so worried about. It's what's happening inside the page, all of the AJAX requests, all of the things that are happening. That's where you start running into some problems, right? So, for example, from the client to the server, a typical request can be anywhere from 500 to 2,500 characters of overhead, of extra HTTP overhead, unnecessary network traffic. From the server to the client, it's usually a little bit less, right? So it's the ratio is usually heavily on the request. Now, there's no exact number on this, right? There's no, like, it's so many bytes. It depends on how the server is configured, your cookies and all of that. And if you really want to tune this, that's an area where you can do quite a bit of good work. You can do a cookieless domain and all of those crazy things. But you can trim it down, but you can't trim it down that much. And if you think about what it actually means, if you make a request and you get a response, the request is actually your upload. And in most people's cases, the upload versus download ratio is in the neighborhood of like 4 to 1. So you have the most traffic on the slowest possible connection. So when you start making a lot of those requests, then that's why a lot of the performance tuning classes always teach, like minimize the number of requests and so on. So there's just no way around it, though, if you have to do that to get your real-time data. And that's where WebSocket comes in. So it's a completely new protocol. So it's no longer HTTP. It starts out, as we'll see later, as with an HTTP handshake. But it's also, so it's a new protocol, but it's also an API, a JavaScript API. So there's the W3C API that we'll take a look at first. And then there's the protocol that's what happens under the covers. As a developer, you don't have to worry about that too much. A nice thing about it is actually sharing the same port with HTTP and HTTPS. And there are new schemes for this protocol, WS and WSS. We talked about scheme host port. This is where that comes in again. And it gives you a full duplex socket connection to a back-end server. And that's actually one of the first lines in the specification. That's important. It allows browsers to talk to a remote host, and I'll come back to that in a little bit. Now, the API is actually, as I mentioned earlier, pretty simple. You create a new WebSocket, and you do that, you create this new WebSocket object, and you pass in the WS-based URL. So this is not an HTTP replacement. You still have an HTTP-based page, and you request the page. The page in JavaScript makes a connection to a WebSocket server. Right, so it's a part of the page that's communicating, opening up that socket for direct connection. And then it's an asynchronous programming paradigm where you add these listeners for all of the events that can happen. Open, close, and so on. But of course, the most important one is that one, the on message. On message is when you receive a message. So far, that's one way of traffic, right? You've received messages. You can receive lots of messages very quickly, but that's only one half of it. The other half is you, at will, can start sending messages. So you can send and receive at the same time, something that is not possible with HTTP because of its half-duplex nature. So you can check support in your browser for this. You can do that. I recommend using Farouk's modernizer, but you can also check window.websocket. It's actually fairly straightforward, but typically these things are better done with a whole team of developers working for you. So window.websocket will tell you that. All right, so a little bit of, actually let me just jump in here a second and give you a quick little demo. All right, so just to step through that a little bit in the code here. All right, so here's my very simple page. I have some script in it. And here, this is just a very basic example. So you check if WebSocket is supported. Now, in Firefox, up until recently, and I think it's the production version of Firefox still has this, you have to check for Moz WebSocket. So it's prefixed, and I believe version 12 or 13 will remove this prefix and will be in production then, but it's not yet. So you want to check WebSocket. Most browsers have implemented this as WebSocket, unprefixed, and then Moz WebSocket. Then the next step is let me make it a little bit bigger. You can create a WebSocket, and it's handy to wrap that in that Moz WebSocket as well, like I did here. And at that point, I add the listeners. So with a few lines of code, I flesh out all the listeners. And I have a send, WebSocket send, with an input message. So if I look at that, here, this is my page, simple page. When I open it, I connect. So I'm now connected to a WebSocket server that I've hosted somewhere on the cloud. And now I can simply use the, well, of course I can try to use the speech input, but there was a problem. Always something. And here, so this is a pretty standard, like it's an echo server that basically echoes back messages to me. Now, that's the basic. Yes. Yeah.
So how is this different than like regular Ajax?
Yeah.
Can you repeat the question?
Thank you. Yeah. So how is this different from Ajax? Well, in Ajax, I would be able to take the input, send it to the server, and the server, let's say, did the same exact thing. It would echo it back to me. So the biggest difference there is sheer overhead. Right? I make a connection. I've established a persistent connection to that server. Now I send this message, and I'm going to show you that in a little bit. I'm only wrapping that message. The protocol is only wrapping that message in 2 to 6 bytes. If you do it in Ajax, you're going to be sending 1,500 bytes back and forth over the network. Now that may be fine in something like this. This is kind of like a chat idea, right, where other people could connect to this, and we could, the echo service would distribute it to everyone. So the problem there is as soon as you start doing a lot of messaging, that becomes a lot of overhead on your server. If you start having real-time data, then you're basically constantly making a poll, right? You're not actually sending the data when it comes in because you've timed your Ajax call on some sort of timer. There are many systems for that called long polling or hanging get, pending post. So there's many problems there because you don't have messages as it happens, so more latency and a lot more overhead. And I'll talk about that in a little bit, right? Right. Yes.
Are you still using TCP packets or UDP?
No, this would be over TCP. So it's reusing actually the same underlying TCP connection. And I'll come back to that. I'm going to have more on that in a little bit. Right. Okay, so give you a little bit more an exciting demo. This was not so exciting. Peter, get it right. Nope. Demos. All right, so what I've done before, so I'm connecting to a server, right? So I make a WebSocket connection. I have a persistent connection open, and I can send messages, and the server can send them back. Now, what if I connected to that with a mobile device, which has a possibility to detect the device orientation, right? And take that data from that regular API call to get that data, or like geolocation or anything like that, and take that data and actually send it to that WebSocket server to do something. So in this case, we've taken an existing 3D, a WebGL canvas, and well, I can control it, I think. No, that's fine. I can control it with the mouse, right? That's from this browser. But actually what's much more interesting is Peter is now controlling this with his iPhone over the 3G network. Right? So it's sending the device orientation details over, we're using like a messaging API on top of WebSocket in this case, but we'll come back to that a little bit later. But we're basically sending that data. It could be just JSON over WebSocket, right? It doesn't have to be very much. It's sending it to a server that can then control this car. So we're communicating I don't know how many hops, but this is pretty responsive. This is just 3G, right?
Yeah, just
Yep.
two things to
Yeah.
add.
Yep.
You guys can try this out as well. If you go to demo.kazing.com, you can try it out from home. And the other thing is that on the phone, all I'm doing is running with the browser as well. So basically the messages from my browser on the phone are sent to the WebSocket gateway, and that gateway channels it back to the desktop in front of here.
Yeah.
So this is not something that you would be able to do with Ajax.
So on the browser, you go to the same, on the phone, you go to the same.
No, you go to a different page. Yeah, so, well, basically, if you go to the demo page, so the demo, so you open a demo on one browser, and then then on the bottom of the screen, it will tell you the passcode to enter from that other URL. So it'll tell you a URL to go to. So you can try this on later, and I'll point out the URL for it. Okay.
And it will only work over 3G or?
No. It'll work anything, right? Yeah, it doesn't matter. Right.
The server is hosted on the East Coast.
It's actually on an East Coast server, so for what it's worth, right? Okay, so a little bit of history. The original idea behind the specification, it was added to this HTML5 communication section, I believe in 2007, 2008, I believe, and it was added as TCP connection. It was Ian Hickson's idea to control a model train from a browser. He was starting to think about that, so hey, why don't we just have a TCP connection so I can run a train protocol in a browser. That was sort of one of the ideas that sparked this, that was behind it. And then very soon that companies like Kazing and other people started contributing to the specification. Actually, here's a picture of the whiteboard at the Kazing office where we pitched the name WebSocket, and that seemed to stick. So that was a pretty cool little picture there. And it went through many iterations of that same protocol. So it actually started out with in one working group and went through 76 iterations there, but only 75 and 76 were ever in production browsers. So the first browser was Chrome, late 2009, and was added to Safari. And then it changed working group, so it started again at 0, so 76 equals 0, and then they started working again on new features. And the most important one there was, and that's the part I was saying, now we're, we have an official RFC since December, so that's great, but also it's added a lot of new features like binary support. There was at a certain point a vulnerability that existed in Flash and Java sockets. They tried out to see if they could do that in WebSocket. They figured, yes, that is possible. So let's stop shipping these older versions of the protocol. Let's fix that. And a good example of how HTML5, how as a community with a lot of momentum behind it, things can really happen, was that in about 6 months' time, the entire protocol was updated and secure. So that same, what they call the proxy poisoning attack, I can go into that offline, is not there anymore in the current versions of WebSocket, but it's still there in Flash and Java. So good reason to move forward with HTML5. Now, when you make that connection, under the covers, and you don't have to worry too much about this, but under the covers, the WebSocket handshake is an HTTP handshake. And this is kind of important when things start breaking. You'll see later why that might happen and what the way around that is. So if you make a connection, you actually your browser sends some HTTP headers to the server. It asks for an upgrade to WebSocket, and then the server responds and says, okay, upgrade 101 switching protocols. Now it strips off the HTTP part and it continues on using WebSocket on the same underlying TCP connection. That's important. So it's not opening a separate connection. It's using port 80 and 443, so you don't actually, like, it's sort of piggybacking in a way on existing infrastructure, which is kind of important. Then you start sending messages or receiving them. Well, I mentioned earlier how these were very minimal overhead messages. There's only a few bytes. There's 2 bytes from the server to the client, about 6 bytes going with this masking to avoid that proxy poisoning attack. is only a few bytes around each message, and that's the powerful thing. That's what really sets it apart from AJAX. Now, if you compare, and this is right following up with that same example, the AJAX calls, when you start doing that, and you start doing 100,000 messages or 100,000 connected clients, all polling the same site, right? And they all send 1,000 bytes of header traffic. Pretty soon, your servers are going to be knocked over because it just doesn't scale. Here's a really interesting example. I've bundled a link here. I'm not going to spend too much time on this, but there's something for you to look at. This is coming from a company that wasn't originally very excited about WebSockets from their early comments, but eventually added it. This is part of Jetty, and they did some recent benchmarking about the latency of WebSocket connections versus Comet, and it's pretty shocking. If you look at the details, and I know it's hard to see, even here it's hard to see, but if you go to that URL, you'll see all the details. This on the left side is Comet, the AJAX calls, right? And this is measured in milliseconds of latency, the bands being 100 milliseconds at a time. The top here is 50,000 connections, and up until about 20,000 connections, it's doing pretty well, polling the server. It gets really, it spikes up to in like this 700 millisecond range for it to kind of round trip with that many connections, with 50,000. On the right side is WebSocket, and what's interesting is they've added another band. This is 200,000 connections. The bands are 1 millisecond each, so that's 100 times less per line here. So this entire thing you can't even see it on the Comet scale, right? So it's that much of a difference. This is a fairly recent study that was done. Pretty interesting benchmark. If you're interested, just take a look at it, or I can talk to you more about it later. And the browser support is good. There are many browsers that support it. IE 10 is actually, I would say, out of all the companies adding WebSocket support, Microsoft has done a fantastic job. They're putting it in the browser, the IIS server, basically the whole Windows Core Foundation libraries are going to have just 3 ways of connecting in general: TCP, UDP, and WebSocket. So it's really moving forward in a huge way. There's also a lot of emulation projects out there. The Kazing WebSocket Gateway has a full emulation in JavaScript all the way back to IE6. There are some plugin-based architectures, like the WebSocket.js is a Flash-based emulation. That may be okay. It gets a little problematic when you start doing Flash, secure WebSocket over Flash, because Flash then requires you to have a policy file hosted on some other port. One of the big benefits here was that you can connect with a WebSocket over port 80. This is actually very, very powerful concept if you think about what may be typically blocked in corporate environments. The ports that you might want to have open are not going to be open, and now with WebSocket you can just come right out, right? So 80 and 443 are the default ports. So there are a whole bunch of WebSocket projects and servers and client libraries. This is just a list. It's not even the complete list, I'm sure. Just an idea of different servers that are out there, and these range from robust servers to prototypes. But you can see, I mean, this is really hitting the mainstream in a big way. Once you have the WebSocket, once you have that communication pipe open, this is where it gets interesting, right? You can start doing something with that. This is, I think, what is really meant to be done. And if you look at the protocol, the way it's been designed, is that you can already start adding protocols on top of that. So typically with TCP, you would do the same thing. You speak a certain protocol, like XMPP or Jabber, to a backend. Or a messaging protocol. Having that same socket, that same WebSocket, now allows you to do the same thing that a desktop application could do for many, many years already, and now you have that same power. You can use different libraries. For example, there's many open source projects like Stomp over WebSocket, XMPP over WebSocket, JMS style Java messaging service like protocol libraries that you can basically plug in, and you speak the higher level protocol. Similarly, you wouldn't probably write a pure canvas game with move to and line to and stroke. You probably want to use a higher level library. If you're building a game, you're not going to go at that low, close to the metal. And that's precisely what is starting to happen on the WebSocket front. There's a lot of these different libraries out there that you can start using. So, right, now, the real world has a lot of, brings in a couple of interesting things. And intermediaries, I would say actually boil it down to just one, which is proxy servers. And to get around that problem, and I'll show you why that's a problem in a minute, the typical best practice is to use WebSocket Secure. Now, the first thing is the dreaded proxy servers, and these are not the proxy servers that you may have configured in your browser. Those are what we call explicit proxy servers. You configure your browser effectively, when it makes a connection, issues a connect header to the server and say, hey, proxy server, I know you're there, pass me to the real endpoint. And many corporations have firewalls and proxy servers that are a central choke point and for caching reasons and so on. Now, the real problem is what are called transparent proxy servers. Transparent proxy servers are there, you don't know about them, but they mess with the header traffic. If you paid close attention, then you know that part of the headers to upgrade to WebSocket is an HTTP header that's added. Well, surprise, the proxy server specification actually says, strip that off. Don't pass that on to the endpoint. Well, you can kind of figure out what happens then, right? So I connect through the proxy server that I'm not even aware of. Proxy server strips off a bunch of headers, and it passed on to the server, but it doesn't know I want the WebSocket connection. Now, a lot of proxy servers out there are illegally, quote unquote, configured to not strip anything off, but they're still expecting HTTP traffic. So as soon as you have upgraded to WebSocket and you start sending WebSocket frames, it's going to probably choke on that. So Google did a lot of research on this, and only about, I think, 65% of regular unencrypted WebSocket connections make it, right? So that's not very good. So what is the answer? Well, use WebSocket Secure. WebSocket Secure, you have to kind of think of it as it's not a different protocol. Similar to HTTPS being HTTP inside of an encrypted tunnel. TLS stands for Transport Layer Security, also known as SSL. Once you have that certificate-based end-to-end encrypted tunnel, you can still start sending your HTTP headers over it. Like the initial handshake can succeed because the proxy server can't inspect, can't look into that. So that's quite important. And so using WebSocket Secure is the answer for most, and I think they got the same connectivity went up to over 95% in real life when you use HTTPS. There are obviously some cases where if you can't get there in HTTPS, you're probably not going to get there with WSS. It's not magic, but it follows in a way that's sort of a, you could say, well, that's kind of cheap, you know, it's piggybacking on existing behavior, but it does mean that you can actually deploy these things today and you don't have to wait for the entire world to upgrade their servers or use different ports and open all kinds of other things. So there's pros and cons to that, but that is, for better or worse, how you can get mass adoption quickly. So what this really allows us is to change traditional architectures that are like application server based, where an application server is building the UI and is giving you a page that is simply just something that's built on the server, maybe some sort of application server that is creating a whole bunch of things on the server side and then pushing it out to the client, sort of an end result of what's done on the server. You now can change that to a more dynamic WebSocket architecture where you use any device, any browser that is now a much smarter client. Like a lot of the logic, not all of the logic, but a lot of the client-side you can use all the HTML5 features to build an application that is as powerful as a desktop application. And basically you can do that with having WebSocket connectivity directly into these backends. And again, this works well with the cores model that we talked about earlier, where you can make connections that can allow certain origins from other origins. So it's not replacing HTTP as the way to get the page to the browser, but once that page is there, it can make many different connections using WebSockets and have dynamic data. One of the big advantages over Ajax is you don't have to re-advertise all of your data every time, because you have a persistent connection and you can have asynchronous messaging in these applications. So chat, gaming, betting, all of that makes perfect sense to use WebSockets for. Okay, so one quick aside here, the server-sent events is another API that you can use for, it's basically a standardization of half of a WebSocket. It's a one-way stream from the server to the client. And what's interesting about that is it does support a few things. Like you could say, well, I could just write a small wrapper in WebSocket to do that, because WebSocket has bidirectional communication, low overhead. Server-sent events has automatic reconnection, event IDs in the case you lose the connection that you can pick up where you left off. Very good for broadcast. Could be a good way to take, for example, news feeds and data sources that are maybe UDP based and make them available over the web, right? So there's multicast networks that sit pretty well behind a server-sent events server that basically just, once the client is connected, just pushes data down to the client. And you don't talk back, and it is a little bit more overhead than WebSocket, but not much. We're talking about maybe from 2 to 6 to 20 bytes of overhead on each message. So it's still very, very low, low network, unnecessary network overhead. The API is very simple. It's just like I said, it's about half of a WebSocket. You create a connection. This is HTTP based. You create a connection, then you add listeners for open when you receive a message, and errors, and that's basically it. There's nothing to send, so there's no other parts to the API. So again, very simple, standardizes a lot of very hard work you had to do to get streaming data into your pages. A good example would be this news feed. Got an example right here, and this is a page with lots of different WebSocket and also like the SSE news feed, where basically you just connect to a server-sent events server that just, as they come in, news items come in, and you can just display them on a page. It takes just a few lines of code to write that. Okay, so this is supported in not as many browsers actually. This is kind of surprising, right? It's, in a way, it's a simpler feature, but not as many browsers have picked it up as WebSocket. But the good news is in WebSocket it's pretty easy to write a wrapper that will do SSE for you. So you could use WebSocket to do it, but then again, you may as well use all of it. Okay, and the final part I wanted to talk about is Speedy. Now this is not an HTML5 feature, and I'm not trying to kind of combine it, but I think it's interesting because there's been a lot of movement on Speedy, and it's pretty closely related if you look at it. So Speedy is actually not an acronym. It was sort of a play on words, like they wanted to speed the web up and do that in a large part, as you'll see later, through compression. So they took the two E's out, Speedy, and that was how they came up with that. The original name for it was Flip, so you may see some of that in the documentation. So this is a new protocol, and it's not an HTTP replacement, but it enhances HTTP. So it's basically an effort to make the web faster. We already saw a lot of the problems that lead to things slowing down and slow page loads. Like if a normal page has, I don't know, 30 to 40 assets, images and CSS and JavaScript, they all need to be downloaded, right? And there's many issues that come into play. For example, you can only make so many connections to one origin at one time. And so there's the connection count and all these other things that slow things down. And HTTP, as we've seen, is not perfect, but once you start doing some of the things that they've done on top of it, you can really make a pretty dramatic improvement. In fact, you can use WebSocket over Speedy. So like I said, it's not really an HTTP replacement, but it is more along those lines. The way you can best picture it is it always runs over TLS, right? The SSL connection. So you have the same basic infrastructure, except you're in another layer, a Speedy protocol layer that encapsulates that HTTP, but also compresses HTTP using data dictionaries, because you could see a lot of the headers that you're sending that I showed you in a couple of cases already. There's a lot of similarities, right? There's a lot of stuff that can be shrunk down, and they were able to compress 85, 88%. Remember what I mentioned, how the upload usually has the majority of the bytes? This is a problem, right? For like your page load time will be a lot better if you can avoid sending that much data. Now, of course, that does set up an encrypted tunnel, so that's not free either. But the general feeling right now is that that's where things are heading anyway, and I'll have a little bit more on that later. So it does other things too. So it uses what is called NPN, or Next Protocol Negotiation, to very quickly, it doesn't use the upgrade that WebSocket uses, but it uses basically it tells with the initial request, say, hey, I want to speak Speedy over SSL. So it sets that up in one shot, and that saves another round trip time, which is expensive. It allows you also to do some server push, so there's a bunch of extensions and experiments that are being worked on still. Multiplexing is the big thing, because you can multiplex the same connection and get many resources over that same connection. You're basically creating a tunnel, and you want to get as many as you can. And what's nice about that is a lot of things we're doing today to improve performance, things like using data URIs for images, they really don't need that as much anymore using Speedy, because it's already all compressed. You have the same, there's not that additional overhead making 90 connections for all of your images. It's all already multiplexed, and you can use a lot of that in that way. So some of those things will start shifting. So there is something called HTTP pipelining. It's not really the same. It's definitely not very standard, and many browsers don't have that. Well, no browser that I know of has that turned on by default. So in reality, that's been difficult to put out there. And so right now, you have basically that TCP connection. A lot of the things are multiplexed over, and at that point, some of the things like the subdomains for spreading the number of concurrent connections become less of an issue, but of course are not a problem. Now, you might say, well, isn't that a lot of overhead to create that SSL connection first? And it's actually less than was expected. So there was extensive research done, again, at Google. This is, by the way, a Google project that is being proposed as an official standard. So it's an open standard. They're open sourcing everything, but it was developed by Google to, and it's already deployed. If you're using Google today, if you're using Chrome, then in 95% of the cases, you're actually using Speedy when you connect to Google backends. I'll show you that in a second. So there are some big advantages to that. One, you don't want to send any data unencrypted that is sensitive, of course. Also, it wasn't, like with today's processors and so on, it's not nearly as bad as people had expected it to be. And in some cases, with the next protocol negotiation, it can actually speed things up. Also, one of the things is, again, the same exact idea that was behind what I was just talking about in WebSocket. It's sort of piggybacking on existing web architecture. And, you know, this Roberto Pion, he has a nice, I have a link to his presentation at the end. He said it pretty well. We want to have some chance of getting this protocol out in our lifetime, right? Because you want to use existing web architecture. You don't want to have to say, well, okay, to do this, you need to set up new servers, open new ports, and all of that. That's just not going to happen very quickly. So this is one of the reasons, besides the fact that there is a general trend. If you've ever been in a an internet cafe and you've used Firesheep, it's pretty scary. You want to definitely use HTTPS or WSS in many cases. So Speedy, by the way, is not a new scheme. It still has that initial HTTP handshake. You would never see a Speedy URL. It always starts out at HTTP and then it just upgrades, it creates that tunnel for you. Right, so if you use Chrome, 95% of the time at startup it's randomized, and because they want to do a test to compare it with people that are not using Speedy, the results are pretty impressive already. There's also a WebSocket over Speedy that you can turn on right now in the low-level settings. And if you go to Chrome //net internals, there's a whole page, and you can look. You probably have this already. You have multiple Speedy connections. One of the nice things about Speedy, it doesn't require anything on the client side. It's just a drop-in thing. If your server, you have to have a server that supports it, but once you do, there's nothing else that the client needs to do to make any API calls or anything like that. Firefox now supports it as well since version 11. It will be the on by default in version 13. You can turn it on right now and already experiment it. It's a noticeable difference if you're using Gmail or something like that. It's definitely something you can really tell. I have like my personal Gmail, and then my work is also on Gmail. So I use like Opera or Firefox in the past for my personal mail, and it's like, oh, it's so slow. All right, questions. So the question was, what's the support on mobile devices? There are two really good websites. Can I use? You just type in a couple of letters, WebSocket. Need another one. Okay, there we go. So that tells you the support on different mobile browsers. It's not as good as it could be. Well, it is on Safari. Well, okay, so the light green there is actually an older version of the protocol. So that's version 75, 76 that are previous versions that are supported. So it's like what Peter was showing us, actually working on the iPhone. Surprisingly, so it has just recently landed in Chrome on Android, including the binary support. But yeah, so those are the support. So in many cases, you will need some sort of fallback system to make sure that it works and goes through everything. So when can you use it in production? Where's the spec at? So one of the slides I had in there was showing the history of it. And since December last year, it's an official RFC. Everything, so the API is in candidate recommendation. So it's done. Now it's a matter of time that browsers catch up so that they have the latest version. That's happening pretty quickly. Firefox and Chrome already do. Safari, for example, needs to update to the latest version. And then, of course, on the server side, servers need to implement it. So it's a little period right now of some stabilization, I think a couple months, and then we'll see, then it's pretty much final. Yeah, that was pretty good, yeah. No, so the question was, will you get a speed difference or an increase in speed if you use another port? So the default ports are 80, 443. If you could use another port, I don't think the ports have anything to do with it. So you wouldn't, as far as I know, you don't get any improvement. Why do you think you would? Okay. Right.
Localizing the traffic and not stepping on.
Yeah, I mean, if there's other congestion on that same, then yeah, I mean, but there's nothing specific to the port, right? There was a question there. I'll come back to you. Yes. Just the question was, what happens when you have this long-lasting connection? Maybe I'm rephrasing it. Tell me if I'm wrong. And what happens? Like, how does it? Like, it's a persistent connection. When does it close? So that's mostly a server implementation. So there can be some configuration on the server that says, okay, well, but it is kind of meant to be a long-lasting, persistent connection. So it's not timing out after 9 seconds necessarily. But then also a lot of things, and this is specifically left up to the higher level protocols to implement, because some protocols may have something to do there, others don't. There was a lot of work put into making it really as close to like TCP as possible, just not implementing any protocol-specific features because they might not work for all protocols. So it's a server implementation, right? If I understood you correctly, it was about reconnect, automatic reconnect. Yeah. So automatic reconnect is not part of WebSocket. There's actually, I think Vanessa sent me a link to it just a couple weeks ago. Somebody had implemented an automatically reconnecting WebSocket because that's something you would think you would want to do. But again, WebSocket doesn't want to get in the middle of defining what a protocol should or shouldn't do. So in some cases, it's fine to just disconnect and leave it disconnected. So it's pretty easy because you can listen for errors and close events. And based on that, you can very quickly reconnect. And then based on that, actually, a lot of higher level protocols are implementing failover systems. Like at Kazing, we've done a pretty interesting thing with load balancing, what we call peer load balancing. So we set up a load balancer that you go to, basically just to get an address to a server that you want to connect to directly. Once you have that and you disconnect, it detects all of that, and then it reconnects again to where it started. Like it reconnects to the load balancer. It says, oh, you go to node 2, done, right? So it's sort of the load balancer getting out of the way of that direct traffic. But that's probably more than you wanted to know. So a lot of different programming languages have their own socket frameworks. So for example, Python has a twisted socket framework. What you're looking at here is you're moving away from connect, or like request response. So you have a lot of sockets open. So you need a different architecture on the server to handle lots of, like for example, if you assigned a thread to every connection, then very soon you would be out of business. So you need a socket framework, a modern socket framework. So Java has Java NIO. Python has Twisted. Node has what is called Socket IO. And Socket IO is basically that same framework you're looking at. So every one of those, and the nice thing about Socket IO is, like, I mean, you would not think that Node, which is basically running JavaScript on the server, could be as fast, and it can't be as fast as things like Java and C++. It will never be that. But it's actually pretty amazing how much they've gotten out of that, and already sort of, as far as I know, already faster than Python, which is compiled. Right? So pretty interesting. And if you have, so first of all, it's like, what are you most familiar with, language-wise? And then you grab one of the servers, like Node.js. Kazing has a complete developer bundle ready that you can just play around with, see how it works in action. There's, like I mentioned on that slide, there's, I don't know, 25 different server projects. If you want one in Python, that's out there. Apache has a module that you can plug in to do the WebSocket support. Jetty, I mean, the list goes on and on. All right, so thank you, and now we'll